Hello YouTube viewers, welcome back. This is a new video on water methanol injection. There are lots of kits available in the market, and today we will be discussing about the methanol injection, what is it and why we are using it, and how much water or how much methanol we must use for the maximum benefit, maximum output, maximum power. And I will be discussing about the different types of kits available in the market. So back in 2011 I started to install this methanol kits. That's a natural aspirated car. It was a snow performance. That's installed in 2011. It's in Qatar, and the outside temperature was very high, like 40 plus. So these cars were more powerful. It was compared to the other cars, it was making a lot of power, and people were crazy why this car is so powerful. And these are some installation. Basically, there will be a pump, high pressure pump. There will be a tank which stores the methanol, and through this piping, the methanol is injected on the intakes to cool the air. So basically, a methanol injection kit adds something look like this, with a tank, a high pressure pump, a controller with piping, nozzle, wiring, harness, and charge pipe where the nozzle goes in. For example, here, see, that's a nozzle connected to the charge pipe. So basically, it's a chemical cooling system. So if you search methanol injection, you can see lots of brands, lots of kits available. AEM, Snow Performance, Devil Snow, Alkai, Cooling Mist, Aqua Mist, lots of brands available in the market, because nowadays this is getting more popular, not like before we used to install this on a natural aspirated car. Now this is a must on a forced induction car, especially it's upgraded. So when you see this, you can see one thing in common, which is the pump. The pump, it's same for all the kit. Any kit you buy, you get the same pump. It's a high pressure pump, and it's very good. It's long life, and it does the job. So now we will move on why we need a methanol injection. So let me open this figure. What it means is, you see the horsepower in this axis, y-axis, and this is intake temperature on x-axis. You can see in Qatar, ambient temperature is between 40 to 50, but the intake temperature will be 10 to 15 degrees higher, which is 50 to 60 in summer. So as you can see, when the temperature goes high, the horsepower drops, and when the temperature is lower, the horsepower is higher. So basically, we need a cold air going to the engine to make more horsepower. So we can say the temperature, air intake temperature, is proportional to the horsepower. Less temperature, more horsepower. That's a basic thing. So we want to lower the temperature. That's the basic idea, and we are using chemical like a methanol or water, or a mixture of water, methanol, to cool the charged air. This is the basic idea. So now, on a forced induction car, what you see here, it's the temperature rise above the ambient. Let's say in Qatar, it's like 40 degrees here, and whatever you see, it's plus 40 plus whatever degrees shown here. So this is an example for a forced induction car, because it's most commonly used in forced induction car. In natural aspirated car, nowadays people don't use it because it's worthless. So let's say when the air is compressed, it temperature is increased based on the pressure. How much temperature is rise? It's based on the pressure. So here, let's say it's increasing the pressure by 8 psi, so the temperature is rising. Basically, the idea is when we increase the pressure, one second. Sorry about that. One error message came. Okay, so basically when air is compressed, its temperature is increased. This is laws of thermodynamics. So when we suck the air from ambient 40 plus 0, we compress it, so there is an increase in temperature based on the how much we are compressing it. Then when it passes from the compressor, like a turbocharger, to the inlet or intercooler or whatever, there is a rise in temperature from the metal parts we use, because intake sometimes it's plastic, aluminum or any other metal. When the air is passed through the ducts, it increases the temperature, and all the parts is inside the engine room, and that will increase another rise in temperature. So the total, from outside the air is increase until it is reach like a total. From there we have to reduce the temperature, and we use the intercooler. So basically from a higher temperature we are lowering it to a certain level, and this temperature is limited because the intercooler, maybe it's air to air or air to water. No matter what kind of intercooler you are using, we cannot cool the air below the ambient. So this is the limit. So this is the ambient temperature here, and we cannot cool it below that. That's efficiency issues between the intercooler and lots of parts. There is heat losses. So basically with the intercooler there is a limit of cooling. And what if we want to cool it beyond this point, beyond ambient temperature? Let's see a next figure. That's a normal setup on a forced induction car. Okay, so air is going here, it's compressed and the temperature is increased, and from here it drops, and it goes to the engine. Since all the intercooler are made of metal, after a long time this metal itself will be at ambient temperature and the efficiency drops, and that's shown in here. In here we are using methanol injection after the intercooler, and we are trying to cool the air. So same thing happens until here. From here we are cooling the air below the ambient. Whatever the ambient temperature is, we are cooling it below it. So let's say normally if the ambient temperature is like 40 degrees, intake temperature will be 20 degrees more, and after compressing and all this thing, it will be higher and higher. So once you start the injection, this temperature will be lower than the ambient. That's the point. Normally I have seen 30 degrees lower than the ambient temperature. That's a good thing about water methanol injection. We use it for cooling the charged air. More if you get cool air into the engine, you get more power out of the engine, and you can tune it for a higher torque, like you can go more timing, lots of other things which is related to tuning. We will be discussing it later. So this is my part 1 video where I will discuss about this, and in the part 2 video I will be making it soon, and I will be giving a proper idea of where to install, how to install, where to locate the injector, which size it's good for you. Now let's move on to the types of methanol injection. So basically, in olden days, there was only one kit available for natural aspirator, and as you can see, there's a controller, there's a wiring diagram. There will be a controller and there will be a pin, like a signal connection from the ECU or any sensor, basically throttle or map sensor or MAF sensor, any kind of sensor which gives a 0 to 5 volt to the controller. Based on that, you control the injection. This was the basic kit back in 2011 for natural aspirator car, and still it's the same for a natural aspirator car. So we discontinued using this because if at any case, if this controller get damaged, it will give a back voltage back to the ECU, damage the ECU, and you can prevent it by using a diode. But normally I stop using every kit which have a connection to the ECU or a wiring harness on the stock, because we had some bad issues. And this one, it's a standalone kit. It has no wiring connection connected to any of the wiring harness on the car. So it's a clean installation, and if you want to remove it, you remove it as it is, no cutting, no connection from anywhere. It's a complete standalone kit used for a forced injection car, work based on boost. So this one is a purely based on a boost. It's a boost switch with a variable boost controller. You can adjust the boost. It can select a trigger point at which it starts working. That's it. So it's just on off at a certain boost. So you set the boost here. So based on your tune, let's say if your car is tuned for 22 psi boost, I will put this one at 20 psi. So whenever the car reaches 20 psi and above, it stay on. The pump works and it starts the injection above 20 psi, 21, 22, anything above 20, the pumps keep working and it keeps a methanol injection stay on. This is the one of the best kit I have ever used, and this is one of my favorite. Not the brand, but this setup, the trigger based on the boost. This is what I mean. That's the one of the best kit I have ever used, and it's safe. It never goes wrong, it never stop working, and it's always give good result, and one of the cheapest in the market. Now let's move on to advanced kit, which is the one here. And see, they are started using nylon tubes because we had issues with the plastic tubing. It normally get hardened because of the temperature inside that engine room, and it start leaking. Nowadays all the kits, they use AN fittings, steel tubing. It never get damaged and long life. Okay, let's come back. So this kit, this is one of my favorite now, because for a high power cars, like with cars with a turbo upgrade or a higher boost, this has a 2-stage injection. That's the beauty of this. It has a high flow rate pump. All the fitting is nylon. It has a controller where I can adjust 3 things. The starting at let's say I start the injection at 10 psi. I maximize the injection at 15, and when the car reaches 20 psi, I can activate a second injector using this trigger. This is a solenoid. I can use this as a stage 2 controller. So we can have a multi injector which activates at different trigger points. On this one, we had a single trigger point, right? The other one, it's having like a more switch and more pump to get different trigger points. Why we need this trigger point? It's because the flow is constant. The flow is constant in the sense, let's say from 4500 rpm you reach 20 psi boost and you start an injection, and as the rpm increases there is more flow, but the methanol injection, it's same constant from 4500 rpm all the way to red line. The injection is constant. That's the disadvantages of a single injector. So if you go for this kit, I mean multi-stage, what we can do is from 10 psi to 15 we can activate one nozzle. From 20 and above we can activate a second nozzle. So based on the boost, based on the RPM, you can get more flow using multiple injector. So basically most of the kits in the market now, it's based on the boost. Now no one is using 0 to 5 volts, and that's a good thing about that. The kits are getting advanced. Only thing is this is forced induction. We use 4 injector, 1, 2, 3, 1 behind it. This is before the intercooler on an X5M. The setup we used in 2011, but right now we don't use this kind of setup anymore. Now let's talk about the ratio. That's the magic part. So from my experience, I have seen is when the methanol injection, water and methanol is mixed with 50-50, that gives the best result. And I will tell you the reasons. When we use water and methanol at a 50-50 ratio, then it's not a flammable fluid. It doesn't evaporate if you store it in the car or in the tank, inside the tank. It doesn't evaporate. So it's a safe liquid. Even if it's leaking, it doesn't get fire. That's the safe side. And for cooling, you can see the dyno torque. It's the highest when you use methanol at 50-50. You can see 50-50 methanol and water. And the red one, it's race gas VP M103, 103, yeah, and that's a pump gas, black one. So this graph says, as per this graph, when you use water methanol at 50-50, it gives the maximum torque, and tuning is all about torque. So what if you use 100% methanol? So let's say in older days, all the pipe like this nylon pipe with a quick connector. If you are using 100% methanol, then you are using the methanol injection for a secondary fuel. Pure methanol as a fuel, it acts as a fuel, it burns. So when you are injecting, you are actually putting more fuel, so you are making the car richer. And a good tuner, he must know, if you are having a methanol injection, you have to tune the car and compensate the methanol injection. And let's say if your methanol goes low and there is no more methanol, and you push the car, there is a higher chance for the car to go lean, because you don't have a secondary fuel anymore. And if you have a leak in any of this kick connector, then you are in trouble and the car catches fire. There is a risk of fire, that's what I mean. And from my experience, 80-20, 80% methanol, 20% water, or 70% methanol, 30% water, it's a kind of good thing about modern cars, because It's all about atomization. If you don't have atomization, it it gives misfire on the car. That's the problem. So based on the setup, it's there's lots of things based on the car, based on the model, based on the nozzle size, based on the location. There are lots of things involved, which I will be discussing in the part 2. And wait for the part 2. And thank you for watching my video. Please subscribe. Feel free if you have any doubts. Feel free to ask. And thank you for watching. And see you on the part 2 video. Take care.